maybe a metro rail. So that is what is first mile connectivity. So in the coal mine, first mile connectivity is the dispatch of coal from the pit head to the silo or maybe the rail sidings. And then it takes taken out from the mine towards the consumer by other means. So by a merry-go-round system or by trucks or whatever. So first mile connectivity only is that part within the mine where the coal is being dispatched from the production phase to the phase where from it is going to be taken out of the mine. So FMC in coal mines, this is just kind of a brief on that. It's the transportation and loading of mined coal from the pit head to the nearest railway siding or dispatch point. So this particular thing has been done in various ways, and FMC is mostly having the principles of rapid loading through silos, and it is trying to minimize the truck transport and trying to get the benefits from that. So how is it? So we are going to talk on that. So integral parts, if you can see here, limited or no direct truck transport, limited or no manual railway siding operations. I'm still saying it's limited because the FMC is yet to take a full force in all the mines. It is in the initial stages. And then conveyor belts for coal transport from mine pit head to the bunkers or silo. Conveyor belt to connection to coal transport from bunkers to CHP silos, and then of course closed belt conveyors for emission control, and automated and rapid coal loading into rakes from the silos. So this is mostly what FMC actually incorporates. And these are some flyers of Ministry of Coal and like WCL, how they have advertised that they are going into this FMC mode. So these are some of the things that I collected. And because it's a flagship project, as I said, of Ministry of Coal, because decarbonization is in effect, and we are trying to actually decarbonize this sector. So challenges are huge. So this is just the speech outline. I'll not go into this. So this is, in the Lingaraj, what we found was this is how the Lingaraj mine operates. Like, for example, you all are knowing that from the pit head, you can have coal handling plant, and from coal handling plant you can have a ground, semi-ground bunker or overground bunker from which coals are taken into silos through conveyor belts. And conveyor belts can be of many types, and people are working on it, how to minimize sound of conveyor belts, how to minimize the fugitive dust emissions from conveyor belts. So there are closed conveyor belts and other kind of conveyor belts people are designing to minimize dust emissions to the extent possible. And apart from that, coal can also go to the coal stockyard. From stockyard, it moves by trucks outside. So truck transport is still on in most of the mines, but it is getting minimized. So this is how transport scheme of Lingaraj looked like. Gevra also has a little bit of more, as when we did the project in 2021, they had more of FMC kind of, it was in effect more than Lingaraj, and it had coal transfer points and other points where from coal was conveyed to the silos. There were 4 silos, and from there it was being transported, and there were truck transport as well because it was not fully phased out. So these are some of the pictures how they actually operated. This is in Lingaraj, and this is in Gevra, and so of course these are parts of first mile connectivity. And so they were operating railway sidings as well, where manually loadings were done. And there are silos also through which the merry-go-round system was taking the coal out. And if I say that potential environmental benefits, because we are trying to still understand, it's a kind of, it's a computation plus, it's a kind of a scenario generation. If we do FMC, what could be the environmental benefits? So I can't say that we have very, very specific data to always come to a mathematical number. It's not always possible. So what we do is, based on the database available, because data keeping is also not always the way we want it for the computations. So based on available database, we try to understand how a scenario can be generated, which shows that yes, it has potential benefits. Whether the mine can reach that potential is a matter of kind of a debate. But of course, there could be many efforts. So what we see is, it's a kind of reduced payloader emissions, fugitive emissions at railway stations should be lowered, reduce steeper diesel consumption, reduce steeper tailpipe emission, because we are phasing out the trucks mostly, and then reduced road dust emission. Road dust emission is a huge problem in mines because it's a dusty environment, trucks move, and road dust emission takes place. It would be in tons, I mean thousands of tons per year if you calculate. And then carbon sequestration by vegetation. Of course, that is a common activity in mines, but that can be revamped and kind of redefined in mines to have more carbon. So these are the potential environmental benefits. And we try to also find out how this emission would be actually taking place if you are taking coal to the railway sidings, manually loading in the rakes, or you have a system where silos are being used for rake loading. So this is just a kind of pictorial representation where from the emissions are actually taking place. So you can see that if the coal is being dispatched to the silos and coal is being dispatched through the railway sidings, in railway sidings lots of payloaders and lots of dust emissions takes place because of loading and unloading, which is in open. So that is why, and of course the payloaders also run, many payloaders are running all the day, so they have diesel consumptions, they have tailpipe emissions, lots of fugitive emission is there. So if you are actually doing it through conveyor belts, which are properly managed, closed and covered, you have lots of dust saving or savings of air pollution through aerosols. So that is one of the primary benefits, and you are also not running trucks that much. So that's why diesel consumption is also reduced heavily. There is one challenge that will come later in the last slides. So what we did was we tried to break up this entire issue of environmental benefits into sub-benefits, small benefits, so that you can understand the potential where from you can gain the advantages, environmental advantages. So this is what we did in our project. We tried to see how the small benefits will accrue to a larger benefit. So you can see this particular slide. I'm not sure how much it is visible, clear, because it's not clear to me from there, so I'll just use this screen. Like for example, a reduced number of tippers and coal haul roads. So the simple benefit is your tippers are being reduced in number, their mileage is reduced, road dust emission is reduced, diesel consumption is reduced. Second is the lower water consumption for dust suppression. Since your trucks are not moving through your haul roads, your road dust emissions are lower, your trucks which are running for dust suppression, fog cannons or whatever, their use will be reduced. So that means you are saving water also by some way. So how much? For that you need to know how much trips are being taken every day, how much trips you're saving now because of FMC. So those calculations come into being. Then lesser coal loading at rail siding, as I said, if you are in railway siding, manual loading and unloading, if it is reduced, lot of dust emissions is being reduced. So that is one very big potential benefit. Apart from that, low payloader operations, since they are using lower working hours, lower diesel consumption and lower tailpipe emissions should be there. And of course, I have mentioned plantation, but plantation is a normal activity in any mine, but that can be revamped through in post-FMC scenario. You can have Miyawaki plantations and other kind of very aggressive kind of plantation activities to offset the carbon emission. So decarbonization has an inbuilt principle of huge and aggressive plantation activities, maybe more than what you commit in your mine closure plan. And then we do a lot of data integration into the kind of computation that we do. And that it's written here like how much trips are taken, how much diesel is consumed, and what kind of trucks are running, because every truck has different kind of emissions and different diesel consumption parameters. So we take each and every data of the entire fleet, we calculate the distance they're running, we calculate or we collect the dust from those roads, from different 1 square meter grids. And based on, we run models. If this many trucks with this much weight are running over this road, having this much of dust per square meter, how much dust would be emitted in a particular trip? So we multiply it by the number of trips and you get how much road emission, dust emission is happening. And if those trucks are not running, then that much emission is saved. So that's how we calculate how much road dust emission will be saved. Apart from that, as I said, we calculate the kind of vehicles data and the tailpipe emission data. We call them as emission coefficients. We calculate based on that the total fleet emission. And if you're not running those trucks, how much tailpipe emission you're saving, that also we can calculate. So we need very fine, or I said very complicated database that we ask from the mines to actually get to these calculations. So this is what we did actually. And finally, our idea was to come to that particular last portion. As you can see, it's the carbon emission benefit and pollution footprint reduction. So that's what we did for Gevra and Lingaraj. And tailpipe emission assessment, I have already told, there are coefficients for each and every kind of vehicle. That if this vehicle runs for 1 kilometer, what would be the emission? Because those research data are available. So we calculate that. And these are the case studies, some numbers that we found. Those are already in that report. So you can see that we have calculated out the carbon footprint studies of your pre-FMC and post-FMC scenarios. And you can see the graphs in which it is shown there. The graphs which are showing lower numbers are actually the post-FMC numbers. That means since these particular mines were already into FMC mode, they could reduce a lot of truck movement and tipper movement within the system. So that's why what happened was in Lingaraj also, they saved a lot of diesel per year, and they also saved a lot of carbon because of lower fleet movement. So that's what we calculated. I'm not going into the numbers because numbers are dynamic. Today, if I go and study the same mine, numbers would be different. Okay, so numbers are not important. Important issue was at that point of time, they were able to save on carbon, on emission, and on diesel, and of course on cost. And this is another number, tailpipe emissions. As again, the issue is you can see the lower numbers in post-FMC scenario. That means they were able to save a lot of tailpipe emissions from the vehicles because they were running in low numbers, much low numbers. And and road dust emission also you can see it reduced a lot because of the lower mileage. So these are some of the numbers, and of course this is the first graph on the left is the carbon sequestration numbers. As you can understand, trees will keep on growing and they will sequester more and more carbon. So that is a normal scenario. Even in non-FMC scenario, mines will do that. But again, as I said, if the under post-FMC scenario, if your plantation activities are very aggressive, and if you have Miyawaki plantation, which is a kind of an urban kind of plantation but can be put in a lot of mines also, mines are doing so. That means very dense plantation with